Hello and welcome everybody to day 25 of Advent of Code on day 25. So first and foremost, Merry Christmas everybody. I've missed the last couple of days. I basically from 22 onwards I just didn't have time anymore to keep getting it done, and the difficulty of the problems was such that I couldn't get them done in the shorter windows of time I had with all the celebrations and gatherings that were on. But today I managed to eke out a couple of hours to get the day 25 puzzle done. The day 25 puzzle is usually not too difficult, so I said I'd just have a look at it, see if I could get it done, and I did, and it wasn't too difficult. Um, yeah, this is going to be the last video in the series. I've decided I'm not going to go back and do the couple of days that I missed, just because I've got some time off now, and I just really want to spend it relaxing away from my computer. So I hope everyone's enjoyed everything that's happened up to now. Hope you've shared in this odyssey with me to try and get this done. I would have liked to have finished it. I would have loved to have finished it. I actually got less stars overall this year than I did last year. I think I got 45 maybe last year. I think I got 43 this year. So I got slightly less far than I did the year previous. But I'm still happy. I had a lot of fun doing this. This whole format is totally new for me. I basically never show my face on my YouTube channel and never talk directly to the camera. So yeah, bit of a new adventure for me. Also, the most amount of videos I've ever produced in such a short amount of time. I had a streak of one video a day for 15 days, and then after that I was one day behind, but still pretty much produced a video every day, except for the last couple of days, where I didn't get any coding done and didn't get any videos done. So here we are today anyway for our last hurrah, and yeah, let's just jump in and have a look at the problem, and then I'll say goodbye to you folks for another year. Who knows? Maybe I'll do this next year. Maybe I won't. I think I might have lost what little hair I had left on the sides here from doing this year, but we'll see. Let's jump into the problem anyway. I'll stop rambling. So, day 25, full of hot air, just like me. So basically, oh, and here's Kimchi to say a final goodbye to all you fine folks as she stares wistfully out into the setting sun here. Anyway, we got a bunch of hot air balloons. They're gonna exfiltrate us from the island, but you need some fuel for them, and because of your cold temperatures, you need a fuel warmer that'll heat up the fuel. But we have some problems. We need to know the amount of fuel in total in advance, and we have that in a list here. Except they're all in these weird numbers, which aren't normal numbers. So as you read down through this, there's a kind of a funny back and forth call with a support person. But basically, these are called snafu numbers. And effectively, they're base 5 numbers instead of base 10. So in a base 5 number, your first digit is the ones, and then the next digit is the fives, and then the next digit is the 25s, and so on and so forth in powers of 5. So that's fine. They're base 5 numbers, but what we're also told is that the digits work differently. So in your normal counting system, your digits start at 0, and then 0 being the absence of anything, and then there's 1s, 2s, 3s, 4s, 5, 6, 7, 8, 9s, and then you would overflow to the next character, which then becomes 10s, and then that pattern continues on for each power as you go up in the numbers. So that doesn't work that way in this number system. In this number system, all we have the digits. So there's ones, two, there's 0, 1, and 2, which behave the same way that they do in normal number systems. Except we also have these special other ones, which are the minus character and the equals, which they call the double minus character. And what these represent is -2 and -1. So the range of our digits in this number system goes from -2, -1, 0, 1, 2. And that's all we can use to represent our numbers. So it's a bit different. Basically what we have to do is we have to take this snafu number list. We've got to convert it into regular just decimal values. We have to add up all the values so that we get some sum at the end, and then we have to input that sum back into the machine that we're messing with, the fuel heating machine. The only problem is you have to input it back into the fuel heating machine as one of these snafu numbers. So once you've got your snafu number and it's all added up, that number at the end, you then have to convert it back into this notation, and that's your answer to your puzzle. So the first part is quite straightforward. The second part is a little bit more difficult, but I'll show you the code. It's not that hard. It's actually pretty straightforward. So let's have a look. Okay, so first thing we're going to do, we're going to go through our file to pull out each of our snafu numbers in the list. And then we'll do this little operation in here on them to basically get the decimal values. And it's pretty easy. I take each digit. I know what the digit is. I map that to this numerals thing I have up here. So I map each of those symbolic ones to a number here that I can use. So then you multiply that by whatever power of 5 you're on. So I also reverse it around so that my indexes go 0, 1, blah, blah, blah. And then I can just use those to get the power of 5, add them all together, and that's it. That's your numbers. So that gives us then here, I have an array populated, and the array is each of those snafu numbers in the input as decimals. Normal base 10 numbers. So then we sum all them together, and that gives us one number. And then what we're trying to do is we're trying to convert that number back into a snafu number so that we can have the snafu number to put in for our answer. So doing this, it can be, I was kind of messing around with a few different ways of looking at it. But it's actually not terribly difficult because basically each number still represents, they represent more or less the same things. Each digit represents more or less the same things as it would in normal numbers. There's just some slight little tweaks that you have to keep in mind. So let's just talk about what we do here. So firstly, I take that number, the big number that we calculated, and I'll divide it by 5. So I use this divmod function, which gives you basically the division and the modulus of whatever gives you the answer for both the division and the modulus for the two numbers you're looking at. So it'll give me a number back, which is how many times, say, 5 evenly divides into whatever the number is, and it'll give me some remainder. I then have to do something with that, and the first thing you have to look at is basically what the remainder values actually are. So for the remainders of 0, 1, and 2, they behave the exact same as they would in a normal number system. So you don't really have to do anything. You actually just take that remainder and we'll stick it into a string up here, which is going to become our snafu number. So if it's any one of them, we just do that. And then basically I've put this inside a loop that'll keep going. So this number will continue to reduce now as we do further divisions. So eventually that'll hit 0 and then we'll break out and we'll be done. So what we do there is so that we've gotten through, we've found our first number, we're going to exit, or we're going to finish to the end of here, and then we'll come back to the top of the loop again. We're going to redo another division by 5 of what was the whole number division result that we got the last time. And then we'll do the same operation again. We can check if it's a 0, 1, or a 2 in the remainder, or we'll see if it's a 3 or a 4. Now, it should become apparent that they're the only numbers that you could have if you're doing, the division, a modulus for 5. You can only have any one of those. So 3s and 4s are the only two cases that we need to think about here. And in this case, we know that if we ever have a number of 3, what we're going to want to do is we're going to want to insert this character, the double minus character. And then if we have a 4, we're going to want to insert the single minus character. And then the number that we're dealing with, we're going to want to add +1 onto that. So effectively, this is like we're carrying a 1 sort of to the next set of 10s, but it's in reverse. I hope that makes sense. I'm trying to think of a good way to explain it, but that's the best I can do. It's like you're carrying the 1 each time, except you're doing it in reverse pretty much. And then these numbers so it's because if you were to take each character, each value, and you were to add them all up, you're basically, instead of carrying 1 forwards, you're sort of carrying an extra -1 backwards. Again, I don't know if that makes any sense. I think that makes sense, though. That's about the best way I can think to describe it. So anyway, you keep doing this operation, and then you flip the string around at the end, and that's it. that gives you your answer. And it's very fast. It runs extremely quickly. It's just very simple arithmetic. And there's our big snafu number there. And that is it, guys. We're finally at the end of this. I've had a tremendous amount of fun. I hope you have too. I hope you've enjoyed following this. I hope I've kept it interesting and light over the last month or so, because some of these challenges they're pretty difficult. I hope you got something from it. I hope maybe this has inspired you to learn some more about coding if you didn't know much about it. Maybe if you didn't take it on this year, maybe I've given you some courage to do it next year, or maybe you just found my voice soothing or something like that. I don't know, but I hope you took something from it. I certainly did. I really enjoyed doing this. I had a lot of fun, and yeah, this might be a regular thing. Maybe I'll do this next year. Maybe I'll keep doing this year on year until the one year I finally get those 50 stars and one video every single day. That'd be the dream. So yeah, I'm gonna keep doing this. I hope you guys keep watching. Thanks to everyone who who followed me through all of this. It really means a lot. And yeah, have fun, guys. Happy New Year, Merry Christmas, Happy New Year, and I'll see you guys next year. Bye bye.